Now, what we will do next, once we have the components of a force. Okay, let's take a look on this problem. Let we have a block and there's a force F 20 Newton, and there's an angle here, and let me give you a good value, 37 degree. And now I will also add another force, which is friction, and to get the force we need something called the coefficient of friction. This is the kinetic coefficient of friction, 0.2. And then let's have the mass here. For example, the mass is 2 kilograms. The first question is, what is the total force on x-axis? Okay, so if you look at the x-axis, first we need to see that there's a component of the force F. Let's call it Fx. And as you've seen previously, the magnitude of Fx is the magnitude of the force F times cosine 37. But please remember, we cannot use this relation all the time, because this depends on the position of the angle. Of course, the position of the angle we have here is between the force with the horizontal axis. That's why we can use this cosine 37. But if the angle is at different position, for example here, then we can no longer use that formula. Okay, right. Now let's imagine when we pull out this object, there will be another force called friction, and we will learn later when we calculate the friction. The magnitude of the friction equals to the coefficient of friction times the normal or contact force here. Now let's see the contact force or normal. Okay, so you know we have another force called weight, which is just the mass times the gravitational acceleration g, and also we have normal. But be careful when you get the normal, because now the normal is no longer mg or weight. Why? If you look at here, we have another force in the vertical direction, which is Fy, right? So we have to find Fy first here, and it's F times sine 37. Okay, now the magnitude of the force F is 20, and sine 37, let me draw this special triangle here, 37. So this side will be 4, and this is 3, and this is 5. Right, so sine 37 is just 3 over 5. Okay, and if you calculate this, we'll have 12 Newton. Now, once we have the Fy, the component of F in the y direction, we can calculate the normal force. So to get the normal force, we can simply use the total force in the y direction equals to 0, because this object is not moving in the vertical direction. That's why the total force in the y direction is 0. Okay, now let's see the total force. There's a normal force plus the component of F in the y direction, Fy, minus the weight, equals to 0. So the normal here is just the weight minus Fy. Okay, so the weight, if we calculate, the weight is 20 times 2 times 10, that's 20 Newton. Okay, 20 minus Fy, which is 12. So the normal force we have is 8 newtons. Okay, so this is the normal force. Now, once we have the normal force, remember the coefficient of friction is 0.2. Okay, so the friction in this problem will be 0.2 times 8, which is 1.6 newton. So this friction is 1.6. Now, we have a component of F in the x direction Fx, which is pointing to the right, and the magnitude is 20 times cosine 37, which is 4 divided by 5. So the Fx is 16 newton to the right. Let me put another color. Right, white. So this is Fx 16, and we have also a friction to the left, which is 1.6 newton. Now the total force in the x direction will be a force Fx to the right minus the friction. So we have 16 minus 1.6. So this will be 14.4 newton. That's the total force in the x direction. Of course, once we have this force, we can now get the acceleration of this object in the same direction, also in the horizontal direction. So the acceleration is just total force in the x direction divided by the mass, right? So we remember that in the x direction, total force equals to m times a. So the acceleration is just the total force here, 14.4 divided by 2, 7.2 meter per second square. So this is one of the examples of Newton's law problems.